Okay, Dr. B here, and let's have a look at structural and skeletal bond formulas. These are something that every chemist should know how to do. It deals with the organic world, the carbon-based world, and a quick way to draw things. We begin by recognizing that hydrogen, oxygen, nitrogen, and carbon tend to form, just about always, 1, 2, 3, and 4 bonds respectively. If you do that, it leads to limited possibilities in terms of how many structures can be drawn. For example, try drawing this structure and you'll see there's only one way it can be done, and that is by just having a linear chain of carbon, carbon, carbon. It cannot be branched. You need four to branch it. It cannot be drawn as a ring. That would make it C3H6, and that's it. That's C3H8. It gets annoying to draw all those hydrogens, and so these skeletal formulas are wonderful. Any end, like here, or bend in the line is assumed to be a carbon, so we don't have to draw that. And all the hydrogens are implied. Can you see that it has just one bond? It needs three more, so they must be three hydrogens. This has two bonds. It's missing two. They must be hydrogens. And like that, CH3, CH2, CH3. Okay, now you know skeletal formulas. Try it for C2H6O, and you might come up with this. This is known as dimethyl ether. But if you're trying to be creative, this also satisfies the honk rules. We could draw the ether like this. We can draw the alcohol like that. The H doesn't have to be drawn, but it almost always is because it's a functional group, and it's handy to know that that has an alcohol functionality on it. In my class, I accept either, but if you look in a textbook, you'll never see just the O. They always add the H. Here's an example of something that can be drawn many different ways. This has either a double bond or a ring in it, and wow, there's a lot of possibilities. I'm just going to focus on this one because we're drawing some wedge-shaped line there and a hatch-shaped line there. Once you have a ring structure, they become spin-locked. If you try drawing this, the two substituents here are locked in place. They can't spin around. And so that means one's going to be up, one's going to be down. We do the coming out of the board with a wedge to show projection. It's typically much thicker up there and thin down there. And the hatches are going into the plane of the board. And it would be best, I think, if it was big there and small there. But it's at least usually a bunch of dots, meaning it's receding into space. That's stereochemistry. You can draw that as a skeletal structure. You have to be explicit about the stereochemical thing here. If you wanted to, you could draw hatches for that hydrogen, wedges for that hydrogen, just to make it extra clear. And that is structural and skeletal bond formulas with a little bit of stereochemistry.